I am the illustrious, prodigal, stupendous, knighted Sir Mr. Dr. Professor Evan Martin Durfee the Great, Third Esquire, Senior Extraordinaire, Supreme of all things shiny, Butcher, Architect, Lord of Hillchester, Birmingham, Charleston, Milltown, and I'm going to show you how to do the area between two curves. Now, Jacob already covered how to do the area between things like that. It's finding that area, f of x minus g of x in the integral. However, sometimes you get things that aren't quite so nice as that. Like you may end up with sine and cosine that you're integrating, or something, some modification of those, and you end up with something weird like that, and you're trying to find the area between this right here. Now, just doing the regular f of x minus g of x dx and the integral between, say, a here and b here isn't going to work because they overlap. So you're going to be adding here and then subtracting here, and you'll probably end up just canceling out a lot of the area. So there are two ways that you can go about doing this. First is you can find the point where they cross over, like let C, and you can do, let's make this f of x, and this one here, g of x. Now you can do f of x minus g of x from A to C. That's like a formal C. And then add that to g of x minus f of x from C to B. So you're taking top minus bottom in both instances since they cross over. So that's the first way. Second way, which is a lot easier, as long as you have the calculator, is just take the absolute value. So you do the integral from A to B of absolute value f of x minus g of x. And dx, of course. And then that'll get you the area between these curves, and you don't have to do any multiple integral stuff. Now, the other things that you might encounter are just this. Say functions of x, like x equals y squared minus 4, and x equals 1 plus y over 3. So for this, you're going to end up with a graph like parabola going that way. It's a really wide parabola, and graph like that. X, y. Now, there are two ways you could go about doing this. If you want to integrate on the x-axis, you're going to need to set up multiple points because you have three graphs that you're going to have to be integrating for the x-axis, because to graph it like this on your calculator, you need to convert it to y equals square root of x plus 1, yes, x plus 4. And that's plus or minus. So you have, this right here is square root of x plus 4, negative square root of x plus 4, and this one right here is 3x, or yeah, 3x minus 1. And since you have these three different curves, you're going to need to take the area between the top curve and the bottom curve up to this point, and this curve minus this curve at this point. So you're going to need 3. And then you would take the area of top minus bottom, add it to the area of top minus bottom, and then you get your area. However, for functions like this, you can do it a little bit easier if you can imagine flipping the axes. So y and x, and then your function looks like this. It's a regular parabola, and you So, as opposed to previous problems where we found the x-intercepts for integration, you only need to find the y-intercepts, and there are two. So, if you need to find the intercepts, we probably already covered this, but just go to calc intersect, just calc 5, and then find the intersection points between the two curves, and then you would do the y-coordinate of the left, or sorry, no, the y-coordinate of the right, so A, B, and then the top, which is 1 plus y over 3, minus the bottom, which is y squared minus 4. Yes, and then you just integrate that in your calculator. And in the calculator, you can't actually put in y, but you can just use x. It doesn't really matter what the name of the variable is for integration in the calculator. But that is how you solve for area between two curves, graph on the y and x-axis like that. So